Hello, this is Bunton with your Visual Functional Mathematics at Level 2, Section 2, Measuring. Today's lesson is Lesson 6 on 3D shapes, nets, and surface areas. The lesson will cover recognizing 3D shapes, working with dimensions, drawing nets and 3D shapes, drawing nets of pyramid, drawing nets of prisms, drawing nets of cylinder, measuring the total area of the surfaces of a shape, and using a net to find the surface area of a shape. We've got quite a bit to cover, but I think it sounds busier than it actually will be. Anyway, let's get on with it. The keywords you will come across, which you need to understand clearly and be able to use, are objects, dimensions, net, pyramid, prisms, and cylinders. We start with 3D shapes, which is on objects and dimensions. Some objects are flat. Flat objects are called 2D objects or two-dimensional objects. Some objects are solid. Solid objects are called 3D objects or three-dimensional objects. As you can see on the right, you'll see a 2D shape, and then you'll see a 3D object. You need to understand that 2D means two-dimensional, so 2D objects have two dimensions. Example, width and height. 3D means three-dimensional, so 3D objects have three dimensions. Example, width, height, and depth. The dimensions of an object tell you its size. The box is 10 cm wide, 5 cm high, and 6 cm deep. That is the box we are looking at now. The dimensions of the box are 10 cm by 5 cm by 6 cm. This can also be written as 10 times 5 times 6 cm. You will need to recognize these 3D shapes. A cube, a cuboid. They have squares and rectangular faces. A square-based pyramid, a triangle-based pyramid. They have a base and triangular faces which rise to a point. You'll also need to be able to recognize these 3D shapes. Prisms. Prisms have two identical end faces that are joined together with rectangular faces. And then you have cylinder, cone, and sphere, a family of shapes that have curved faces. Working with dimensions. You might get a question about 3D objects and the dimensions in your assessment. For example, Bronwyn is designing a box to hold 6 cream cakes. Each cake is a maximum of 12 centimeters long, 5 centimeters wide, and 4 centimeters high. Sketch a box that could hold the cream cakes. Label the dimensions. Think about how you'd put the cream cakes into the box. It would be sensible to lay them all side by side in a row like this, like the drawing you see on the board. Each cream cake is 5 centimeters wide, so 6 cream cakes will be 6 times 5, which is 30 centimeters wide. So the box need to be at least 30 centimeters wide. The cream cakes are all 12 centimeters long and 4 centimeters high, so the box needs to be at least 12 centimeters long and 4 centimeters wide. So you could sketch a box that looks like this on the right of the screen. An important point is, don't forget to give the units when you're writing dimensions. If you're working with centimeters, don't forget that. Practice questions, set 1. Stuart is posting some books to a friend. He wants a box to put them in. The dimensions of the books are shown below. Book 1, 30 centimeters by 4 by 25 centimeters. Book 2, 15 centimeters by 2 by 12 centimeters. And book 3, 25 centimeters, 9 centimeters, and 20 centimeters. Sketch a box that could hold all the books. Label the dimensions of the box. So you have to take size into account and think about how you're going to lay them. Let's see the solution to practice question set 1. Question 1, for example, 30 centimeters by 15 centimeters by 25 centimeters. A cuboid like that. The easiest way to send the book is to stack them on top of each other. So the box needs to be as long and as wide and as deep as the dimensions of all 3 books stacked together. We look at nets now. You need to be able to draw nets. Why? Because when you're designing, you need to be able to show on a 2-dimensional drawing what a 3D object would look like and what the dimension would be. So, a net is just a 3D shape folded out flat. You can use a net to help you make a 3D object. These nets for cubes and cuboids always have the same basic shape, as you see below. For example, draw a net for the cuboid on the right. The cuboid has 6 faces, so a net for the cuboid will be made from 6 rectangles. Draw the rectangle for the bottom of the cuboid first. It should be 11 centimeters long and 7 centimeters wide. Next, draw the rectangles for the sides of the cuboid. They're 11 centimeters long and 5 centimeters wide. And then draw the rectangles for the front and back of the cuboid. They're 5 centimeters by 7 centimeters. Finally, draw the top of the cuboid with the same dimensions as the bottom. And if you look on the diagram there, you see that the first thing you need to do is to draw out the net and, most importantly, label them: bottom, top, back, front, and the 2 sides, and then make sure you measure their dimensions and put it there, so that even if you're not the one who's going to be putting the box together, whoever is doing it will know exactly what you want. We can also do nets of pyramids. The net of a pyramid will be made up of its base and all of its triangular sides. A triangle-based pyramid is drawn on the right. The base is equilateral and the sides are isosceles. Draw a net of this pyramid. We know now that equilateral means the triangular base has equal sides. That's what I mean by equilateral. The 2 lines of each section are 9 centimeters long. They are all equal. And looking at the solution, this is what we expect to get. Let's go through it. The pyramid has 4 faces, so its net should be made up of 4 triangles. Draw the triangular base of the pyramid first. It's equilateral and the edges are 7 centimeters, all 3 edges. Now draw the 3 sides of the pyramid. Each side shares an edge with the base. These triangles are isosceles. The diagram shows that the 2 other edges are 9 centimeters long. You should end up with something that looks like the star shape on the right. Practice questions Set 2. Which two of the shapes on the right could be the net of a triangle-based pyramid? A or B? Question 2. A square-based pyramid is drawn below. Its base has a width of 2 centimeters. Its sides are isosceles triangles. Each side has a height of 3 centimeters. Draw a net for this pyramid. Draw it on a page with a grid line that enables you to label it properly, and use one square as 1 centimeter. Answers to practice questions sets 1 and 2. Question 1, A and D. Question 2, there is a drawing of what you're expected to do. Nets of prisms. The net of a prism is made up of rectangles and its 2 faces. Example, draw a net of the triangular prism on the right. The prism is made up of 2 triangles and 3 rectangles. So you see that the triangles are the base and the top, and then the rectangles are the side. And you see the dimensions there. That's very, very important. You also know how to calculate the area of a triangle and, of course, of rectangles. Since the shape is a prism, the triangles at the front is the same as the triangle at the back, and we use those as the base and as the top. The solution. Draw the rectangles first. Use the diagram to work out their dimensions. Then draw the triangles so that they each share an edge with one of the rectangles. The dimension will tell you the size of the prism. Try to imagine your net being folded back up into the prism. If it works, there is a good chance that you've got it right. So in design, and we call it testing. So there are many ways you can test your design to make sure that you are on the right path. And trying to imagine them being put together is one way. Nets of cylinders. A cylinder is a bit like a round prism. It has 2 circular faces joined by 1 curved side. Example, draw a net of the cylinder on the right. It has a radius of 3 centimeters and it has a height of 7 centimeters. The solution. When you draw the net of a cylinder, the curved side flattens out to a rectangle, so that's easy. The rectangle has the same height as the cylinder, and its width is equal to the circumference of the cylinder. That's the distance around. So you need to know how to calculate circumference. So the diameter is 2 times the radius, which is equal to 2 times 3 centimeters, which is 6 centimeters. Circumference is equal to pi times diameter. We know that pi is 3.142. Times 6 is equal to 18.849 centimeters. Draw the rectangle, then draw the 2 circular faces anywhere along the edge of the rectangle. And that is what you're expected to do on the right. Practice question set 3. The net of a prism has been drawn below, and that's the net. And what you have to do is, which of the 3D objects above, A, B, C or D, does the net belong to? Question 2. A cylinder has been drawn below. Which diagram, A, B or C, is the correct net of the cylinder? Note that the dimension of the cylinder has been given, so you need to check because those drawings might not be accurate. And your answer, question 1, C. And question 2 also is C. Check them out and practice with them. Let's look at surface area. Surface area is the total area of the faces of a shape. Sometimes you might need to work out the surface area of a shape. This is just the areas of all the faces of the shape added together. The cuboid below has two faces with an area of 91 centimeter square, two faces with an area of 70 centimeter square, and two faces with an area of 32.5 centimeter square. So what do? We simply add them all up together, which will give us 91 plus 91 plus 70 plus 70 plus 32.5 plus 32.5, totaling 397 centimeter square. When you're doing exercises like this, you just have to be systematic and make sure you check what you've done. Surface area is the total area of the faces of a shape, as I told you earlier on. The third point is, if you only know the dimensions of the faces, then you'll have to work out the areas. Okay? You remember the previous example, you were given the areas. In this case, you're given the dimension, but as long as you know the dimension and you know the formulas to use, you're okay. Calculate the surface area of this cuboid. 1. The faces of a cuboid are identical squares. So when you know one size, you know the other size. So they each have a length and width of 2 centimeters. Area of faces is equal to length times width, that is 2 times 2, which is equal to 4 square centimeters. The cube has 6 faces, so its surface area is 6 times 4, which is 24 centimeter squared, or 24 square centimeters. Practice question set 4. The base of a pyramid on the right has an area of 25 centimeters squared. The 4 other faces each have an area of 15 centimeters squared. What is the surface area of the pyramid? Question 2. Calculate the area of the cuboid on the right, that is the surface area. You'll see that you're given the dimensions and you know the formulas to find rectangles. And your answers, question 1, 85 square centimeters, and question 2, 94 squared centimeters. We now look at the use of the net to find the surface area of a shape. If you need to find the surface area of a 3D shape, it can be helpful to draw a net. Drawing diagrams is important. Jason wants to find the surface area of this prism. He starts by drawing a net of the prism. What is the surface area of Jason's prism? And there is your drawing. What do? Use the net to work out the area of each surface. Work out the area of the rectangle, the 2 different rectangles with the dimensions, and then work out the area of the triangles. Because it's a prism, we have 2 triangles, base and top, and then you have the sides to think about. Okay? So 8 times 3 divided by 2 is equal to 12 centimeters square. That is the area of the triangle. 9 times 5 is equal to 45 centimeters squared. That's the area of one rectangle. And then 9 times 8 is equal to 72 centimeters squared, which is the area of the other rectangle. So what do? We add everything up. Don't forget the number of sides. So the surface area is 12 plus 45 plus 45 plus 72, which is equal to 186 square centimeters. Let's use a net to find the surface area of these following shapes. Example 2. Calculate the surface area of this cylinder to 2 decimal places. When you hear about 2 decimal places, know that you have to use pi. Okay, so you have a cylinder 3 centimeters radius by 7 centimeters high. So start by drawing a net of the cylinder, and that is your net. Now use the net to work out the area of each face. Area of cylinder is equal to pi times radius squared. So 3.142 times 3 squared is equal to 28.274 centimeters squared. In case you're wondering why I got 3.142, that is the value of pi. Now add up the areas of all 3 faces, which is 28.274 plus 28.274 plus 131.94, which is equal to 188.495. Rounded up to 2 decimal places, you have 188.50 square centimeters. By the way, you see 50. Normally when you're using numbers, when you have 2 decimal places, one ending in 0, you just leave the 0 out and say 0.5. But in this case, you are specifically asked to round up to 2 decimal places. So please don't forget these little hints. Practice test, set 5, question 1 and question 2. 1. The net of a triangle base pyramid is drawn on the right. Its base has an area of 6.93 square centimeters. The remaining faces are identical triangles. What is the surface area of this pyramid? Do you understand what we mean by identical triangles? They're all the same, all equal. Question 2. The net of a cylinder is drawn on the right. What is its surface area? Give your answer to 2 decimal places. And there's the diagram to help you. Question 3. Amy has made a model house from a solid cube and a solid triangular prism. The house has a height of 10 inches. Amy has started to draw a net of the triangular prism on the grid below. Complete her drawing and label the dimensions. 1 square on the grid is equal to 1 inch. Look at the model and then look at the grid. Remember, the dimension you have to use is 1 square grid is equal to 1 inch. And you have to draw accurately. B. What is the surface area of the model house? And your answers. So practice question 5. Question 1, that is 6.93 centimeters square. Question 2, 25.13 centimeters square. And then there's your drawing of the net. And then question 3b, 264 centimeters squared. Please read the notes that follows. It helps you understand what you're doing. And before we go, let's look at a summary of what we've covered. You've covered the following: how to work with objects and their dimensions, how to identify the properties of 3D shapes, how to draw nets of 3D shapes, how to draw nets of pyramids, how to draw nets of prisms, drawing nets of cylinders, and how to measure the total area of the faces of a shape. We also have covered how to use a net to find the surface area of a shape. That is our lesson for today. But before we go, remember, attempt all the questions before you check the answers. If you got them all right, do not forget to celebrate by tapping yourself on the shoulder or giving yourself a treat. It's connections and learn from them. That's it for today. I'll see you next week.